Imagine you're standing at the center of a giant compass rose, a symbol that has been used for centuries to navigate the vast and uncharted territories of our world, the kind you might have seen on old maps, guiding sailors across the oceans and explorers through unknown lands. Lines radiate outwards in every direction, each representing a specific degree from 0 to 360. These lines are not just random, they are meticulously calculated to provide precise directional guidance. These lines, my friend, are much like the radials in aviation. In the world of flying, radials are invisible lines of radio signals emanating from ground-based navigation stations. These stations, known as VOR stations, send out signals that pilots use to determine their position and navigate the skies. VOR stands for VHF Omnidirectional Range, and it is a crucial part of aviation navigation. They act as invisible highways in the sky, guiding pilots along predetermined paths. These paths ensure that aircraft can travel safely and efficiently from one point to another, avoiding obstacles and other aircraft. Think of them as beams of light from a lighthouse, only these beams are radio waves. Just as a lighthouse guides ships to safety, VOR radials guide aircraft to their destinations. These radials originate from what we call VOR Stations, which stands for VHF Omnidirectional Range. These stations are strategically placed around the world to provide comprehensive coverage for aircraft navigation. These stations are the unsung heroes of aviation navigation, silently broadcasting those radial signals across the skies. Without them, modern air travel would be far more complex and less reliable. Just like the lines on our imaginary compass rose, each radial from a VOR station has a specific degree associated with it. This degree is crucial for pilots to understand their exact position in the sky. This degree is your key to understanding your position and navigating accurately. By tuning into the correct radial, pilots can ensure they are on the right path, making air travel safer and more efficient for everyone. VOR stations are the backbone of our radial navigation system. These stations play a crucial role in ensuring that aircraft can navigate safely and accurately across vast distances. Scattered across the country, these stations are like radio lighthouses, constantly emitting two distinct signals. Each VOR station is strategically placed to provide maximum coverage and reliability. One signal is omnidirectional, meaning it's transmitted in all directions. This signal serves as a constant reference point for pilots, ensuring they always know the station's location. This signal acts like a heartbeat, letting pilots know the station is active. It's a reassuring presence, a constant pulse that confirms the system is working. The second signal is a bit more complex. It carries additional information that is crucial for determining the aircraft's position relative to the station. It rotates like a beacon, making a full 360-degree turn every 30 seconds. This rotating signal is meticulously timed to provide precise navigation data. This rotating signal is what creates our radials. Each radial represents a specific direction from the VOR station, like spokes on a wheel. Picture it as a sweeping beam of light, hitting each point on the compass rose as it rotates. This visualization helps pilots understand their position relative to the station. Now, here's where things get interesting. The interaction between these two signals is what makes VOR navigation so precise and reliable. The time difference between the omnidirectional signal and the rotating signal is what determines the specific radial you're on. This time difference is measured in microseconds, allowing for incredibly accurate navigation. The equipment in your aircraft analyzes this time difference and displays it as a degree on your navigation instrument. This degree tells you exactly which radial you are on, guiding you safely to your destination. So how do pilots actually use these radials to figure out where they are in the vast expanse of the sky? It's all about triangulation. Triangulation is a method that involves using multiple reference points to determine a precise location. In the context of aviation, these reference points are VOR stations, which emit radials that pilots can tune into using their navigation instruments. Think about how you might use two different landmarks to pinpoint your location on a map. For instance, if you know you're a certain distance from a mountain and a river, you can draw lines from these landmarks to find your exact spot. In aviation, we use two VOR stations to achieve the same thing. VOR stands for VHF Omnidirectional Range, and these stations are strategically placed to cover vast areas of airspace. Each VOR station sends out radials in all directions, which aircraft can detect and use for navigation. Let's say you're tuned into VOR Station A and your instrument tells you you're on the 180-degree radial. This means you're on a line that extends from the VOR station in a specific direction, in this case, southeast. This means you're somewhere along an invisible line extending southeast from that station. But knowing just one radial isn't enough to pinpoint your exact location. Now, you tune into a second VOR station, Station B, and your instrument shows you're on the 300-degree radial. This second radial gives you another line, this time extending northwest from Station B. This places you somewhere along a line extending northwest from Station B. The intersection of these two lines is crucial. The point where these two radials intersect, that's your exact position. By using the intersection of these two radials, you can determine your precise location in the sky. It's like drawing two lines on a map, each representing a radial, and finding where they cross. This method is both simple and effective, allowing pilots to navigate with confidence. This technique is the cornerstone of VOR navigation. By understanding and using these principles, pilots can ensure they always know their position, even when flying over vast, featureless expanses. Now that you know how to determine your position, let's talk about how to actually follow these radial highways in the sky. Imagine you're planning a flight from Airport A to Airport B, and there's a VOR station located midway between the two. Your flight plan might instruct you to depart Airport A and intercept the 090-degree radial from the VOR station. This means you'll be flying due east, directly toward the station. Once you reach that radial, your course will be set to follow it. As you approach the VOR station, your flight plan might then direct you to turn to the 270-degree radial, taking you on a westward course towards Airport B. By following these predetermined radials, you're essentially connecting the dots in the sky, ensuring a smooth and accurate flight path. Section 5. Radials and airspace management. Keeping the skies organized. Imagine the sky as a busy freeway system with invisible lanes. That's essentially what air traffic controllers deal with every day. Radials play a critical role in this organized chaos, acting as the lane markers in our skyway system. By assigning specific radials to aircraft, controllers can maintain separation between planes, even when visibility is poor. It's like having assigned lanes on a highway, preventing everyone from bunching up or colliding. This is especially important around busy airports where numerous aircraft are arriving and departing. Controllers use radials to create structured arrival and departure paths, ensuring a safe and orderly flow of traffic. Section 6. Safety first. The importance of radials in avoiding collisions. In the early days of aviation, pilots relied heavily on visual navigation, which worked fine in clear weather but posed significant risks in clouds or low visibility. The invention of the VOR system and the use of radials revolutionized aviation safety. By providing pilots with a reliable way to navigate in all weather conditions, radials dramatically reduced the risk of mid-air collisions. They allowed pilots to fly precise courses even when they couldn't see other aircraft or the ground. Even today, in our age of sophisticated GPS systems, VOR radials remain a crucial backup navigation system. They provide an independent means of navigation in case of GPS outages or malfunctions, ensuring that pilots can always find their way safely. Section 7. Practical scenarios. Putting your knowledge to use. Let's say you're flying from City A to City B, and you encounter unexpected thunderstorms along your planned route. Air traffic control instructs you to deviate from your original course and fly a heading of 270 degrees until you intercept the 330-degree radial from a nearby VOR station. By understanding how to interpret and follow these instructions, you can safely navigate around the storm, maintaining the necessary separation from other aircraft and hazardous weather. This is just one example of how a solid understanding of radials can be crucial in real-world flying situations. Section 8. Master the radials, master the skies. Mastering the concept of radials is like learning the language of the sky. It unlocks a world of possibilities in aviation, allowing you to navigate with precision and confidence. Remember, it's not about memorizing numbers on a dial. It's about visualizing those invisible lines in the sky, understanding how they connect, and using them to paint your own flight path across the canvas of the clouds. Like any skill worth learning, mastering radials takes time, practice, and a healthy dose of curiosity. Don't be afraid to ask questions, delve into the details, and most importantly, enjoy the journey of exploration. Section 9. Keep exploring. The journey of aviation knowledge continues. The beauty of aviation is that there's always something new to discover, a new challenge to conquer, and a deeper understanding to attain. As you delve further into the world of flight, you'll encounter even more fascinating concepts and technologies that build upon the foundation of radials. So, keep that thirst for knowledge alive. Explore the intricacies of instrument flight, delve into the world of air traffic control, or even try your hand at flight simulation. The sky is not the limit when it comes to expanding your aviation horizons.